A lawn that looks like this may not meet the expectations of the average turfgrass manager, but to a pollinator, it's utopia. At Virginia Tech, we've been investigating ways to incorporate pollinator-serving plants into managed landscapes. And we've done a number of research trials to that end. And what we're finding is the opportunities are near limitless. In this study, we are trying to develop pollinator garden sod, trying to give sod producers the ability to grow a mixed stand of broadleaf plants that are pollinator serving, and then lift that material, sell it, transport it to another landscape, and have the pollinator garden to be able to establish and be producing flowers within a few weeks of sod transplanting. Now the problem is we need a diversity of broadleaf species in order to produce a functioning pollinator garden, and these broadleaf plants are going to suffer much more than grasses will if you sever their roots. So the way we did that was we grow the plants on plastic. So the plastic allows us to have a very knitted root system. What I'm pulling up right here is a combination of common yarrow as the base, which is a rhizomatous broadleaf flowering plant, and a whole host of other broadleaf species that are meant to be pollinator serving. So we don't even have a turfgrass in this system, and yet we can definitely produce a transportable sod. So what we're actually comparing in this study is how different species compositions will perform. And in particular, we've varied the base composition, what the dominant base species will be, the species that we hope will help in knitting that sod together, but also in some cases still be pollinator serving. For example, here we have fine fescue. Now fine fescue is allowing a few species to persist, but for the most part we saw a huge reduction. At times, depending on the time of season, as much as a 70% reduction in both species diversity and density of pollinator serving plants. So fine fescue is giving us a knitted sod, but it's holding back the desirable plants that we want to establish in these gardens. Common yarrow is actually doing arguably a much better job. It's allowing for a greater species diversity to come through, but still giving us pretty good integrity of that sod. We have blue grama grass, which the blue grama is still establishing, but it also, because of the time of year and the overall density that it's going to achieve in a given amount of speed compared to fine fescue, blue grama has allowed for a great species diversity to persist. In our other plot, the base was increased density of white clover, and that one's here in the foreground, and also a very excellent rhizomatous base that's allowing a diverse amount of species to come through. We've also conducted a number of studies trying to incorporate spring bulbs, flowering bulbs, into managed turf. And these studies have also shown some very exciting results, indicating that there are a number of species that can be incorporated into managed lawns, give you an enormous spring bloom, but then be mown away as the turf starts to grow, and the turf is indistinguishable from before the bulbs were established. So you have this dynamic system where the spring blooms explode in late winter and early spring, and as the turf starts to grow, we start to mow out the bulb plants. They go dormant and they come back next year. We're using plant growth regulators to suppress turfgrass growth and give the spring bulbs a longer period of growth and more carbohydrate storage. We're also evaluating how fine leaf fescue compared to tall fescue competes with these spring bulbs. And the data are showing that fine leaf fescue is more competitive and will reduce bloom density of the bulbs compared to tall fescue. This project was made possible through generous donations, grants, or collaborations with the Virginia Department of Transportation, the Virginia Turfgrass Foundation, and the Virginia Agricultural Council.